Right, the stream died on me. Okay, what I found out was because I'm putting an actual capacitor in, I can actually clip my probe directly onto the ground of the other capacitor at the back. So I only have to stick one probe down to test that I've got continuity between the and not a short. I can also check to make sure it's actually soldered to the board properly. I've turned my soldering iron off because I'm running it on the inverter and I don't want to run my battery down. So if I put my meter on DC ohms, why am I saying DC ohms? It's ohms anyway. Now I'll clip my one end of the probe onto the lead that goes to the actual capacitor at the back, so I should get a short when I touch the ground, if I can get there. Yeah, that's it. Now the positive is that one, and it's not shorted, so that's brilliant. We haven't got a short. So I need to make sure that this ground, because I think ground runs all the way around actually. I should be able to get ground touching the chassis. Yeah, I do. So I'm touching the metal parts here, look. So the ground part of the capacitor is connected to the circuit, fine, that's fine, and the positive is not shorting. So the soldering is good, at least as far as, let me just check, let me just put this on ohms on 200k range. I should get a reading between that pin and, yeah I do, I get a 40k reading now, it's dropping to 30k. Yeah, okay, so that capacitor is in circuit. Okay, that's brilliant. So that capacitor that's been plaguing me for like the last 6, 7, 8 months, which I thought there's no way I'm going to get that out of there, I have got it out of there. And that's really awesome, because this was definitely leaky, this red one. It was definitely bad. There's no doubt about it. I've checked it. It was reading like 12 mega ohms resistance on the meter, which means that on a higher voltage it probably read a lot less than that. Probably had a 1k or even less reading on a, with 100 volts going through it, trust me. So my scope should come to life a lot better now that that's out of there. The new one's in, and I'll try and move the camera now, because finish with that view. Right. Move this light. Now I can take the Captain tape off now. I just want to see what damage there is on that wire. I did melt it a bit, but I think it's alright. It's just, oh, it's alright. It's not gone all the way through, it's just softened the outside cable up a bit. I'll leave the Captain tape there anyway. I can take that wire strap off now that was holding that HD cable out of the way. And right, out you come. That's that out of the way. Right, take the camera out. So what looked like an impossible job. You can see how tight, what a rat's nest that is in there. Whew. And basically that, I can move that cable back where it was. This one. I need to put the light back down so I can see what I'm doing. There we go. I've just taken that tension off because it was pressing quite hard. I've just moved it back. So that's where the cable was before. And it was completely obscuring that capacitor down there. So I'll take this off the stand I put it on. This box thing. Oh, it's back on the table. I've chopped my wire for the camera now. Okay, so the capacitor that I replaced is the blue one right there. That's that bright blue one. So it's quite a big one, but that's what was in it. It was a high voltage, so should give it a few more years of life. Maybe 3 or 4, maybe 5, who knows, but it's when the CRT gives up. And it's actual, I've got insulation on the back there, on the leg. And because that actually is grounded anyway, this end of the actual capacitor is ground, so it doesn't really matter about insulation. I only put that there just so that the leg wouldn't short against anything else that had a voltage on it. So that's that done. We're ready for another test run, I think, on the scope. I don't know why it keeps saying lost signal. I don't know what that's all about. I might as well turn the stream off actually now, because I'm pretty much done for this. I'll try and film the rest of this on my phone later. Right, so I'll just put my lamp back down. Clip the camera on here if I can. Right, so let's put this on its back, on its side I mean. Right, okay, I'll raise this up a bit. If I can. There we go. That's the capacitor I've just put in. Such a rat's nest down there, it really is. I just hope I didn't pull any wires off while I was doing that, I really do. but we should be okay. I'll probably run this on my inverter first just to be safe, just to double check everything. It runs on the lower voltage on there. That should sort out my trigger problems as well, because that circuit was for the trigger circuit. Because I always had trouble with the trigger because it wasn't the sensitivity wasn't there, and I'm almost certain that that's the reason why. Is because there was a leaky capacitor on there. So I'm going to turn this around. And fingers crossed I can switch it on. I'll put it on my other. I'll put it on my little inverter first and see if the current, if it trips, because it kept tripping my little inverter. And if there's less current draw, it shouldn't trip it anymore. Oh, that telephone number is just a technical support company in the UK. Just double checking stuff. Well, I've got it right way around now. Make sure that other cable is still attached. You know, the one I was pulling out with the pliers. It looks like it is. Yeah, it's okay. It's hard to tell. Oh, I stick it on its side again because yeah, that looks good. I can see my soldering actually. Yeah, that capacitor does go through that coaxial. It is connected to that by the looks of it. Where's that wire go? I don't know where it goes, but it's got high voltage going through it. By the looks of it. Let's hope it's not shorting on there. I can't really tell. Right, C2 it says. C2. Well, that's the connection. 2C and C2. I want to look on the manual on the circuit actually. I want to double check this. C2 and 2C. I need to find that. I know it's near the vertical amplifier, so right. $110 rail. Has to be that side of the resistor though, because it's right next to it. So, where the hell is this 2C? Oh yeah, can't see it. I certainly hope I haven't shorted anything across there. I'm going to have to try and get my meter across that, just double check, see if it is connected to that. Alright, it's hard to tell. Right, that's C2. Where the hell did that wire go? I'm just afraid to turn it on at the moment until I've just verified this thing, because that 2C is ground actually, so it could be going anywhere. Well, I wouldn't think they would put a connection so close unless it was meant to be connected to it, so I'm not going to worry too much. Because it's literally about a millimetre from where I saw the capacitor in, so I just hope I haven't got a short there. Hard to bloody tell. Oh, I'll look at the, of course, I'll just have to look at the circuit plan. You know, there's a plan, a printed circuit plan. That will tell me what it is. Of course, silly me. Right, I was just still struggling trying to see it. Just go to the circuit board plan. Right. So, oh, it's actually 33C there. Right. The capacitor I took out was where is it? Let's see. Oh, lost my page now. Right way. Let's see, 702, is that the one? I'll go back again. No, it's C56. So C56, the one I've just taken out. So where's that C56 on here? Oh, it's at the top, silly me. I'm looking in the wrong place. Right, C56. Connected to ground. Yeah. No, hang on, that's C58 there. I can see 2C anyway. 2C is ground. C 2C is ground and C2 is something completely different. So it appears that yeah, that coaxial cable does connect to that capacitor because there's two pads connected together in a string, and the only thing on the other side is ground, so that's not shorting out enough. In fact, I already checked that. So I'm basically looking right here where my fingernail is. You probably can't see it. I'll turn that bright light off, it's too bright. This is C50 C56 here, right here, and there's these little pads that run along, and the coax is basically connected right here, so it is connected to that capacitor. So I assume that we're taking some power from this supply rail here and routing it through coax to another part of the circuit, which appears to be what's going on. And be better if I get this in the PDF actually, because yeah, I'm going to open the PDF. It's a lot easier to see it. Right, so which one do I want to open? Right, I've got the wrong PDF open. I want the one with the circuit plans, and it's not on this one. I put it on the other one. Is it that one? Yeah, this is the one. Okay, let's zoom in. Now C56 was somewhere around here. There we go, that's C56, that's the one I replaced. Right in the middle of the screen. And as you can see, that smooths out the power for the that goes for R80 15k and R56 18k. Definitely high voltage because of those high values. And it goes to the trigger circuit, which was always giving me trouble. There's a gain down here somewhere. Horizontal position. Yeah, that C56 just had to be replaced, and I'm glad I've sorted that out. Right, let's go to the next. That is the horizontal amp, and that's why I was having problems with. I replaced quite all the other capacitors on there. Now I need to look at the printed pattern, which is down here somewhere. Here we go. It's wrong way up as typical. View, rotate, right, zoom in. Right, C56, right, the top there in the middle. As you can see, there's those connections are really close together. Right, here, all these connections, and the coax is basically connected somewhere around about here, so it's not shorting out, so that's good. At least I verified that. I wanted to be sure. And to do that, all I have to do is stick a probe on the coax and between ground, and it should be good. Which I'll probably do. So, put the meter back on. There's my torch. So, if I get my meter down here somewhere, if I can, which I can see where the coax is, so if I connect to the coax, I'll click the other end onto the ground. Just a minute. Put a ground lead on here. Put my meter on this end. Now you can't see what I'm doing. 2D mix, I think, 3D mix or whatever. And now that shouldn't be shorted. No, it's not. That end is ground. Yeah, that's the shield. What am I touching now? I'm touching that screw. Right, okay, that's good. Okay, that I'm relieved. Oh, there's actually more than one wire coming out of there. There's another. It's three core. It's two inner signal leads, and one's power and one's signal. That's obviously why. Right. Okay, I'm happy. I'm happy. So take that off. I can connect it up to the power now. And I'll see if I can get the camera looking at it if I can. I need to put this on something else really. Oh, I'll get my step ladders, that's an idea. I've run out of chairs. Yeah, one chair's full of stuff. Right, if I put this on this step ladders, I can get the camera pointing at it. Right. Okay. That feels so much better getting that damn thing off my bench. I tell you, it was just. Ugh. I just couldn't move on here. I couldn't move with stuff. Right, let me get this angle right because it's cockeyed. Which way does it want to go, right or left? Oh, it's cockeyed again. Flipping thing. Hang on. That's better. Right, okay, we're ready for a test. Is anybody watching me, or should I just kill the stream? Because I don't know if anyone's watching or not. I suppose I could edit this down and use some of it later. Can't be asked to edit stuff these days. Such a lot of effort, and I've got other things to do. Right, let's plug this into the inverter. I'll put it in my little wires trapped. Flippy wire, come out. I want to stick this on the little inverter first because it tends to trip when it gets a higher load on it. It's the heaters on the CRT that tend to draw quite a bit of current, really. Let's see if this trips this one, which it probably will. Right. I'll turn it on. It'll probably trip the inverter, and I'll stick it on the bigger one if it does. Yeah, it did. Yeah, I'll put it on the bigger inverter. I thought it would. I was hoping it wouldn't because that capacitor's a better one. Right. We should get a much wider beam now. Fingers crossed. Nothing yet. Oh, here we go. You know what? The beam is a bit better. It seems a bit wider than it was. Do you remember a few months ago when I was doing this, my beam was kind of collapsed into the middle. There was a gap on each side. Well, it's a full width screen now. Which is really, really good. Probably needs running for a while before I actually put the lid back on, because I basically just want to monitor it for any smoke or anything. I just want to make sure that the magic smoke doesn't come out. Right. Both beams are working, but notice when I put the other beam on how the primary beam dims a bit. That's the HT that's a bit low, but I'm not worried about that. It's probably the HT caps won't changing too, but I honestly aren't going to start messing about with those. They're expensive. Ordering 3 450 volt electrolytics at 15 microfarads each is going to be very hard and not cheap. I could probably make them up out of some of the polyester ones, or high voltage polyester ones actually, but I am not going to spend all that time doing that when it works and it does what I need it to do. One beam's good, 2 beams is better, but I can live with 1 beam. Looking at the drift between each voltage setting, there's a little bit of drift, but that's nothing. There's nothing going into it right now. That just means that, well, actually this knob tends to get turned when I turn this other one anyway. I think the knobs are rubbing. Cleaned all the switches with some switch cleaner. Yeah, I'm happy with that. That beam should get wider as it warms up if the capacitors are good. Once some of them capacitors really need a good charge. Actually, they need that big new one I put in, that 450 volt one. It would be what you would call well, it just needs to recover a bit, right, because it's been sat for a long time, so it needs a high voltage to rejuvenate it a bit, just for it to bring it back up to its full potential. So I do expect to see this beam getting a bit wider, the width get a little bit wider as it settles down. I put all the trimmer pots back to the original positions because they were all marked on the board with bits of nail varnish where they used to be, and I'd found out I had to keep turning some of them up past the point where they used to be because it was going down slowly, and now I've put them all back to where they originally were, and that's where it should be. So it shouldn't be far off calibration. It's probably a bit out, you know, it's probably a few volts out, but it's good enough for what I want really. It's good enough for doing tests and experimenting and things, and when you're not really worried about voltages, you're more interested in voltage tweaks and peaks and things like that. So it's good enough for that. It's good for years and years ago when you were calibrating TV sets. Having a scope that was properly calibrated was very important, but not so much these days. Televisions, well, we don't really use these kind of scopes on really. It's all digital now, isn't it? It's digital stuff now, so it's not the same as it used to be. Times change. Let's see how much brighter it'll go. Yeah, it gets a bit out of focus as I turn the brightness up. Which is a sign of a weak tube, but certainly better than it was, that's for sure. Yeah. I'm just going to run it. Actually, I'm on the inverter right now as well, but I am going to run it for a little while on the inverter just to build it up a bit. But I'm not going to run my battery down, so I'm going to set my alarm at 15 minutes. I just want to run it for 15 minutes on the inverter really, and then I'll put the case back on. And the other scope that's kind of off camera in the distance is the one that a friend loaned me, but you can't really see it, it's kind of behind that one. Actually, when I put the ×5 thing on, which is when you pull out this one, it's a lot wider. That's ×5 width. That's working as well, but it's a bit dimmer. And it's not actually, it's bang on these edges of the screen. That's where it's supposed to be. You know, that's exactly where the beam's supposed to be, right on the edges. And look at that, it's perfect. If I move it a little bit, it just shows a gap on this end. Move it back, and we have a gap on this end. That's exactly right how it should be. A full width screen, not too far. And when you pull it out for ×5, it's 5 times the width. So that's bang on. I want to watch for instability. I'm leaving it running for 15 minutes because I want to see if there's any drift, because any drift is indicative of a bad circuit somewhere, a bad capacitor. But I've replaced all the capacitors now, so all the important ones anyway. So if it doesn't drift, it means it's good. It means it's stable. If it drifts, it means it's unstable, obviously. So I'm not injecting a signal or anything right now. I'm basically just want to check the actual scope without any signal going in, because otherwise I'm going to have a signal, another source with potential change factors. So I just want to just check itself against itself really right now. Oh, I want to see how much current it's drawing on the inverter, because the other day I checked it was about 2 amps. So let's see what it's drawing. You're able to see this though. that's good. It's about 1.5 amps now. Yeah, that's good. It's actually drawing 1.5 amps. Yesterday it was about 2 amps, so I'm actually drawing less current now than I was before. So this scope is definitely a lot. It's not losing energy through bad caps anymore, because caps are obviously, there's a short in the caps. It will load it down more. And that beam is bang on the centre. It hasn't drifted up or down. Sorry, up or down. Getting upside down now. But normally that beam on the centre line, after it's been on for a few minutes, it starts to move up a bit or down a bit. And it's not actually, I'm not even on full mains right now. I'm running it on the inverter, so it's only getting 200, about 190 volts right now, and instead of 240, so it's doing really well. Sorry, yeah, no, it's just under 200 volts. These inverters they're rated at 220 volts. These inverters are, but they're running on they're not running on 12 volts input. They're actually running on 11.6 volts input. So they're actually putting out a bit less on the high voltage than what they should. So it's only getting about 200 volts, I think, because obviously the inverters work by stepping up the voltages by multiplication. I can't say the bloody word. Anyway. So another 7 minutes and I'm going to turn it off. I'm going to call it done, put the case back on, and then it's time for coffee. Actually, I could go and put coffee on now, I think. Boil the kettle or something. I think I will actually. I'm dying for a cuppa. I'm sure you guys would roll the dice if it caught fire or anything. Just checking for radiation with my Geiger counter. None. Still bang on the centre. I don't know why it is, but it actually looks brighter on the camera than it really is in real life. CRTs are kind of strange things. They seem to glare more on the camera than it actually is here. It's not very bright here, but it looks brighter on the camera. I don't know why that is. The camera must be picking up the ions or something that you can't see with the naked eye or something. Probably infrared. Well, that's the time. I've timed it for like, it must have been going 20 minutes actually. So I'm not going to run my battery down. I need to put the case back on it actually and test it for stability again, so I'm going to turn it off now. Anyway, I'm going to end the stream, put it all back together again and run it on proper mains next time and test it again with the case on, because obviously it'll behave differently with the case on because it'll get warmer. You know, there'll be more stability issues with it with the lid on. So that's worth doing another test when it's all put back. Lone Wolf quarters. I'm just laughing at what she was tight.